Okay, today we're covering Newton's second law, and we'll start with the definition of it. It's when an object experiences an unbalanced force, it will undergo an acceleration proportional to the net force. Huh? Okay, it means this. That we've done our diagrams here, and before we've had forces that have always balanced each other. Okay, and because of this, our acceleration is equal to 0. Okay, or there's no change in motion. That doesn't mean that it's not moving. It just means that its motion isn't changing. It could be traveling at a constant velocity. It could be not moving at all. But whatever the case is, if all of the forces are balanced, then it's not changing its motion. Its velocity is not changing. It's not increasing or decreasing. In this case, however, we have an unbalanced force. That somewhere in all of the forces acting on our object, okay, we have an unbalanced force. We have something that is causing our object to change its state of motion. Okay, so it is changing. Okay, it is changing its motion. That means its acceleration is not equal to 0. Okay, it has an acceleration, and because of this, we have an equation. And the equation that we mentioned, that is implied up here, that it will undergo an acceleration proportional to the net force. And it means this. And there's two ways of writing it. The way Newton wrote it, because he invented all this stuff, is that the force on an object divided by its mass equals its acceleration. But we don't like to write it like this. We don't like fractions. We like, typesetters like writing everything on one line. And so what this really is the most famous equation in all of physics, that force equals mass times acceleration. I have these little lines over it because that means that wherever the direction of the acceleration is the same as the direction of the net force. Okay? And so the way we talk about this is the net force come on. Okay, that the net force is equal to the acceleration on an object multiplied by its mass. F equals mass times acceleration. And it's in the direction of, and that the net force is in the same direction as the acceleration. And that's really about it. Okay, but there's some cool things that happen with this. And we're going to, if we have an object, I got you. Okay, and it has this velocity. It's going in that direction. Okay, and we want to get it to stop. Okay, we need to exert a force on this thing to get its velocity to change to 0. That makes sense? Okay, so let's say it has this, let's say it's moving at 5 meters per second to the right. We want to get it to 0 meters per second, right? Okay, we want to get it there. 0 meters per second. Okay, and let's say this whole thing occurs in 2 seconds. Going from 5 meters per second to 2 meters per second, 5 meters per second to 0 meters per second in 2 seconds. And the object has a mass of 2 kilograms. You with me so far? So it's going to be something roughly like this, okay? And it's moving at 5 meters per second, and we want to know, figure out what force do we need to get this to stop? Force over 2 seconds to get this to stop. Yeah? Okay, so here's the thing. Our acceleration is our change in, if you remember back to what our velocity acceleration was, our definition of acceleration. It is the rate of change of our velocity. So go ahead and go back and take a look at your notes. Find it in there. Okay, go to the table of contents if you're not sure where to look. Okay, velocity is the rate of change of our acceleration. I'm sorry. Acceleration is the rate of change of our velocity. Okay, so acceleration equals the change in our velocity divided by the change in time. Remember, that's what those deltas mean, is that it's the change in our thing. So, what is our change in our velocity here? It's right. It's slowing down, which means our change is a negative 5 meters per second, right? We go from 5 to 0, and so our change is a negative 5. Yeah? And it occurred over how much time? It occurred over 2 seconds, right? Okay, so our acceleration over this time period is going to equal, what is that? It's negative, and 5 divided by 2 is what? 2.5, yeah. 2.5 meters per second squared. That is our acceleration over this time period. But we know that our force equals mass times acceleration. So what's the force acting on this object? Well, it's going to equal our mass times our mass times our acceleration, right? Right, which means we get our force equal to 2 kilograms times negative 2.5 meters per second squared, which gives us 2 times 2.5 is 2 times the negative 2.5 gives us negative 2 times 2.5. Well, here, check this. If we divided 5 by 2 to get 2.5, and then we multiply it by 2 again, we're going to get negative 5. and it's negative 5 kilogram meters per second squared, which equals negative 5 newtons. And so the force acting on this guy, the force needed to stop this in 2 seconds, was negative 5 newtons. Yeah? You guys see that? Okay. That's the idea behind Newton's second law. I kind of complicated this a little bit, made it a little tougher than what you're probably going to see on the next part of your homework. But this is the idea behind Newton's second law. And all forces, the force and mass and acceleration, this is the basis behind why things move. Things move because there's an unbalanced force acting upon it. So let's zoom out here. See if we can get this whole thing. All right. So when an object experiences an unbalanced force, it will undergo an acceleration. Well, we've talked about acceleration being a change in the state of motion, right? That's how we get a change, where our motion is changing, is due to this unbalanced force. That is governed by F equals ma. Our force equals mass times acceleration. Okay, and so another way of saying this is the net force is equal to the acceleration multiplied by its mass. And here's our example down here of how we figure that out. Okay, so that's pretty much it for Newton's second law. Although it gets deeper than that, it all boils down to the same principle.